Hello, this is Britt Caswell with another video. This one is covering multiplying binomials in a method called the box method. There are several ways to multiply together binomials or polynomials. I usually prefer the distribution method, but I find that the box method is actually very useful for students to help them visualize what is happening. So coming to our first example, we start by drawing a box, which I'm sure is quite surprising to you guys. Now, what we're doing is we're multiplying binomials, so I'm going to be creating a 2 by 2 box. But if I had some other type of polynomial, say I had a trinomial here with 3 terms, I could easily just add another set of boxes on here. So this box method is useful for binomials, but it can be used for any range of polynomials. Once you've drawn your box, then you take the binomial and you write one of them across the top, as you see here, and you write one of them down the side. Some students compare this to the Punnett square, which you do in biology. The next thing that we do is we need to find the area of each of the smaller boxes. So in this case, I would take the length of the box, which here is x, and multiply it times the width of the box, which is another x. So x times x is x squared, and I'm going to write that area here inside the box. And I would continue to do that for each of my other boxes. So here I have an x times 2, which is 2x. Down here, I have an x times 3, which is 3x. And then in my last box, I have a 2 times 3, which is 6. Once you've found the area of all of the smaller boxes, the way in which we find the area of this really large box is we actually take each of those smaller areas and we add them together. So I'm going to add x squared plus my 2x plus my 3x plus 6. Now recognize, guys, that when you do this, you want to collect your like terms. That is, you want to collect the terms that have the same variable to the same power. In this case, it's my 2x and my 3x. If your polynomial or binomial is written in its standard form, these like terms appear across the diagonals. So if you don't want to do the extra writing, you can just look across your diagonals and combine them right away. So the final answer here is x squared plus 2x and 3x makes 5x plus 6. And there's our final answer. Now when you're doing these box methods, I'm going to set up my next box. But when you go to write your polynomials across the top, make sure that whatever sign is going with the second term stays with the second term. That's especially important if you have any negatives showing up. So here I have my x plus 1 across the top and my x minus 7 down the bottom. So my top left corner, I have x times x, which is x squared. And then I have negative 1 times x, which is negative 1x. You can write that as just negative x if you want. My bottom left, I have negative 7 times x is negative 7x. And then lastly, I have a negative 7 times a negative 1. Now remember, a negative times a negative makes a positive 7. So then when I go to add together my like terms, again, I'm looking across the diagonals. So I have an x squared. And then across this diagonal, I have a negative x and a negative 7x. That's a total of negative 8x. And then lastly, I have my plus 7. And this is my final solution for this box problem. So now my third example, if you notice, now we're starting to get a little more complex. Now there's coefficients in front of the x. They aren't just x. You'll find this still works the same way. So I put my 2x plus 1 across the top of the box. I put my 3x minus 1 down the side of the box. Now remember, for these, when you go to multiply them together, you're going to multiply the coefficients together. So 3 times 2 in this case to get a 6. And then you add the exponent of the x. So x times x makes an x squared. Many students make the mistake of accidentally adding together that coefficient, or they make the mistake of multiplying the exponents on the variable. Going to the next part of the box, 3x times 1 is 3x. Sorry, my pen keeps changing sizes. Going to my bottom left, negative 1 times 2x is negative 2x. And then lastly, negative 1 times positive 1 is negative 1. So now we are all set to go through and collect our like terms. So across my first diagonal, I have 6x squared. And then here I have a 3x and a negative 2x. So 3 minus 2 is a positive 1x. And then I have my minus 1 there at the end. Now this final example is one that is very common in factoring. And it's a pattern that you should start looking for. Okay, this is a concept called conjugates. So a conjugate is when you have a binomial and you are multiplying it to another binomial where everything matches except for that middle sign. Okay, so conjugates are very easy to recognize, but they have a very powerful property to them that makes simplifying them so much easier when you go to multiply them together. So here I've written them across the top and across the side of my box. So now when I go to multiply, I have 3x times 3x. That gives me 9x squared. I have a 3x times 2, which is 6x. I have negative 2 times 3x, which is a negative 6x. And then lastly, a negative 2 times a positive 2, which is negative 4. So when I go to collect these terms, I have my 9x squared. But when I get to my linear term, I have a negative 6x and a positive 6x. So when you add something and subtract that same value, they completely cancel each other out. You will find that that happens every single time that you have conjugates occurring. And then I have a minus 4. So when you go to multiply this together, you don't end up with a trinomial in the end. You end up with a binomial in the end because those middle terms cancel each other out. If you continue in the video series here, you will see that pattern come forward as I continue through factoring. So this multiplication method again is called the box method. I will be doing the same set of examples with a method called the distribution method in my next video. Thanks for watching.